title of today's presentation is From Theory to Practice, a practitioner's journey with knowledge graphs. So let's start with the journey and how the journey has started. So the journey has started in Wrocław in June of this year, where I was presenting the presentation of my team regarding the AI agent that was combination of LLMs and the knowledge graphs. The second part of the journey was in London during the summer, where I had the chance to attend many AI meetups and met a lot of people. And the thing that was super common to both experience was the same question, because when I was introducing myself, I was saying, oh, I'm just doing the knowledge graphs. And the main question was what are the knowledge graphs? So before we go into that, I would like to just shortly describe who am I and what I'm working and why I'm talking about the knowledge graphs. So I'm Patryk. I'm working for almost 6 years at the DataWalk, which is Wrocław-based startup, which is developing the knowledge graph platform. And I was doing like a lot of different work on that company. So I was the data scientist, solution architect, and currently I'm the R&D team leader. And in terms of the implementation that we're doing, and I was seeing and doing them, and the experience that I will be describing today is based on this kind of the customers that we are working with. So like a lot of different financial institutions and law enforcement agencies. Okay, so let's start with the knowledge graphs. So what are the knowledge graphs? So there are like many different definitions. So I just came up with one more because why not? So this is the one that I very like. So it's the knowledge graph is semantically enriched informations organized as the interconnected entities, properties of those entities, and the relationships in a graph structured data model in order to mirror human intuition. And I just want to emphasize that mirror human intuition because it will be very important in the later part of the presentation. And when I think about the knowledge graphs, there are like two layers of the knowledge graphs that are very important to in general, the knowledge graph as a concept. So the semantic layer and the technology layer. So let's go to the first part of that, and I will make a little bit note on the technology layer. So when we think about the graphs in general, so the first thing that we have in mind is the technology that we want to use. And when we think about graph database, the Neo4j is something that are like many people are very familiar with. But it's only like very small small item on the whole landscape of the technology regarding the graph databases. Because what is the Neo4j is a representative of the something which is called property graphs or labeled property graphs that represent the graphs as a set of the entities, relationship, and properties. And one of the another vendors of the property graphs is the Tiger graph, but there are like many more. But what is very interesting is that it's not the whole landscape of what is possible in terms of the graph databases, because there's a second category of graph databases, which is semantic web or RDF style knowledge graphs, which represent the graphs as a triples. So the subject, predicate, and object. So we've got three items to represent the specific represent the graph. And there are some examples of the vendors that's also providing the graph databases. So for example, Cambridge Semantics or the Stardock. So let's move forward, because we don't have enough time to just go into the whole details, so let's move forward. So let's talk a little bit about the semantic layer, which is a very crucial part of the knowledge graphs. So there's like quite a, let's say, longer definition of what are the ontologies, which is the crucial part of the semantic layer. So what are the ontologies? It's a formal representation of the knowledge, which is very important part. We are talking about the knowledge, which has a rich set of the relationships among various entities and concepts, which is very interesting. And the goal is to enable machines to understand the semantics of the data, so what we are dealing with. And what is important about those ontologies, it enables to create a standardized and shared understanding of the data within the companies or within the organizations that are adopting the knowledge graphs. So let's talk a little bit more about the details of the ontologies and how you usually construct the knowledge graphs. So first of all, we've got something which is called, let's say, domain ontology, which represents the knowledge of the specific domain that we will be working with. And obviously, it's only, let's say, the general description of the knowledge that we've got. And also there's a second part, the data itself. So we've got the instance data, which are the instances of the specific concepts that we've got in our knowledge graph. So let's consider one of the examples. So on the left side, we've got the example of the domain ontology. So for example, we can have the person, and one of the subclasses of that person can be, for example, ambassador, president, or artist. And in terms of the instance data, we've got few examples. We've got the John Smith, we've got the Andrew Long and Kim Long, and we've got the specific association with the specific classes. So we see that the John Smith is the instance of the ambassador, we've got the Andrew Long, which is the instance of the president, and also we've got the Kim Long, which is representative of the artist. And let's consider the example that we wanna to do something with that data. So what we can do for our specific use case that we would like to do is to create the additional part of the ontology that will be describing some specific information that we will reuse using our data. So for example, we can define some specific concept which is politically exposed person. So if we go to the definition, what is the PEP, we will see that, for example, the ambassador and president can be a PEP. And how we can use that? So we are moving forward from the ontology to the second very important concept of the knowledge graph, which is the inference. So because we've got that definition, we could do the following thing. So we know that the John Smith is ambassador. And because in our ontology, we define that the ambassador is also a PEP, we can do the inference that the John Smith is not only ambassador, but is also a politically exposed person. And obviously, we can do the similar thing for the Andrew Long, which is the president, which is also the politically exposed person, which means that the Andrew Long is also a PEP. I would say it's kind of the very simple example, but it has like a lot of consequences, and it can be used in many various places to develop something much more complex. Okay. So we just discussed that theory of the knowledge graph that I want to present to you today. So let's move to the practice. So I would like to discuss with you the implementation process. And there are some few disclaimers that I want to say before we go into the details. So first of all, and I will start with the last bullet, which probably should be the first one. So the work that I will be showing to you is the result of me observing and doing the implementations for a few years. And there are two specific things regarding the process that I develop and that we are using in the company. So first of all, we are dealing with the enterprise data. And probably it's not something that probably many of you are working with, but just to give you a, let's say, brief description what is like to work with the enterprise data. First of all, it's usually a mess. So you've got like many different sources that are super dirty, and you need to somehow work with that. And the second thing is that usually you are dealing with like billions of data. And the second thing is that the process is sometimes DataWalk specific. So maybe it's not one-to-one transferable to the other knowledge graph platforms, but I think it should give you like a brief overview of how the implementation may look like, and I hope that I will inspire you at least at some part, and you can reuse in your specific processes at least part of I will be describing. So regarding the overview, so the implementation process is composed of five specific let's say steps. So the first one is the ontology creation, the second one is the mapping sources, the third one is the data cleaning, the fourth one is entity resolution, which is a very crucial component of that, and at the end we've got the analytics. And at the end, after the analytics, I will show a little bit of the AI. So let's keep waiting. Okay, regarding the ontology creation, so probably that could be a topic like from the itself, and probably we could talk for like an hour only about the ontology. So there's an example on the image of the developed ontology that we can see the different entities that got the different relationships. So what is important during the process of creating the ontology is to codify the expert knowledge. So how the experts that are using the data at the end are thinking about the data that they've got. And the crucial concept of that is the competency queries. So the questions that you would like to answer using your knowledge graph. And I would stop there. There's a very good reference that we started using and adopted to our purpose, which is the ITLOS methodology. So there's a QR code if someone wants to go deeper. Let's go deeper. The next part is the mapping sources. So usually when we deal with the enterprise data, we've got a lot of different data sources, and you need to find some mapping between, for example, one of the databases to the specific part of the knowledge graph, because you can have information about the people in 3 data sets, and you need to find a mapping how to put that to the one data set. It's important part, and usually takes a lot of time, as you may expect. The third thing is the data cleaning, and I wanted to put that slide because not many people knows about those libraries and are super useful when working with the data. So the first one is the address parser, which is the libpostal library, and the second one is the phone number parser, which is libphone number library, which allows you to parse the data to clean that data. And the one important part is that both of them are written in the C or C++, which makes them super fast. And what we did in our company is that we embedded them into the database, which is also quite nice trick to improve the performance, because usually if you work with a lot of data, you really need to scale with many billions of records. The fourth part, entity resolution, that was something that I was super surprised when I joined the company in general and started doing the project. So you need to have the process to identify and link the same records that refer to the same real-world person. So you can imagine that if we've got the 3 different databases and you want to have once like the very clean knowledge graph, you need to have the resolution of that entity. So if I'm in the 3 different data sources, in the end, the analyst would like to see like one person, because I'm in real world the one person. And there's a short overview of the process. So usually you've got the data preparation. So it's not only the phone and address parsing, it's like many different steps. The second part in the middle, which is the crucial part, is the candidate selection matching. So to propose the candidates that will be considered to be the same entity and doing the matching. And the last one step is entity resolving. So sometimes, for example, you want to have a gold record at the end, so like really physical one instance of the data, but sometimes it's not very crucial, it's not possible because of the legal reasons. And there's also a very good guide. It's not written by me, but it's a very good guide that explains in the details entity resolution. And the last one part, and this one is, I would say, a little bit upsets me when I was working during the project, because it turns out that the analytics at the end is not super sophisticated, and what was very surprising to me, it brings a lot of value to the customers, to the end users. There are 3 things. I've got only two screenshots, so let me briefly explain. So the first one is the summary dashboard. So usually what the analyst would like to see is the one single pane of glass that you are seeing the information about specific entities. So for example, when you are considering, I don't know, some suspicious person for the investigation, you really would like to see like the very single view of the person at the end. The second one is to obviously query the knowledge graph and create a rule-based system that allows you to find specific entities in the whole graph. The third thing that is not shown here is the link chart, because we are talking about the knowledge graphs and we've got the graphs, so we sometimes would like to analyze the relationship between different entities that allows you to analyze the whole situation. Okay, so I promise that in the end we'll have a little bit more of the AI. So let's say that it will be like more analytics and a little bit of the AI. So there are 2 practical examples that I would like to show you, and how much value can be bring to the specific customers using the approach, using the knowledge graphs and some additional more sophisticated analytics. So I would like to discuss the graph analytics example for the law enforcement agency that is used in the production, and the second one is the AI use case for the, again, law enforcement agency that we recently did a POC with some help of my team. So first example regarding graph analytics. So let's consider that we've got 2 different entities. We've got the John Smith and Andrew Long, and both of them are suspicious in some specific investigation, police investigation. And the question is there a path between those 2 people? And this question doesn't seem like, you know, super complex and hard to explain. And usually the process starts being you know, more complex when we think about, okay, let's consider all possible paths in the whole system that you've got the billions of data. And the problem now starts to be, you know, super complex. So we are able to do that. And what's the effect? So the effect is that when the, you know, analysts or investigators are doing the, the process of finding the bad guys, the investigation usually takes weeks of manual work by clicking in the system and, validating different specific paths. Now it's like the 3 clicks on the system, and you are searching for all possible information that you've got in the system. So I would say it's pretty impressive. It also brings, makes the world, let's say, safer place. The second example is the AI for law enforcement. So this one is very, very interesting. So there's something which is called Cellbrite. So this is a software that allows the police to, for the suspicious people, take their phone and download all the data that you've got on the phone. So when you think about your phone, there's a lot of unstructured data that might be very interesting and very important for the investigation purpose. So obviously you will have a lot of images, a lot of text, and a lot of audio. And the problem is that if you're the investigator in that specific case, you need to check all of them. And when there's a lot of data, it's super hard to do that. So what we did for one of the customers for the POC. So first of all, we started with the audio. So when you think about the possibilities of the AI system that we currently have, you can obviously transcript that audio to the text. And working with text is a little bit more easier. So what is the second thing that you can do when you've got a lot of text? So for example, first of all, you can extract entity and relationships, because you would like to know, for example, for that specific phone, what are the connections with other people that were present in the whole phone, and you would like to analyze and the relationships with that. And obviously you can formulate based on that the knowledge graph. The second thing is obviously you can use some LLM to do the summary of the text, and you would like to, for example, score them and find what is suspicious, what is not. And the last one thing is the images. So you can detect objects. The interesting part regarding that is that we might want to detect some objects that are not well defined in the open source model by design. So for example, if you think about the law enforcement agencies, what you would like to see is the guns. And usually gun is not a label in the standard data set, but there are some models that allows you to write the open vocabulary and just write gun. It turns out that it works, that we are able to find guns and create the knowledge graph. So what we can do and what is the value of that? So the effect is that rather than checking the whole phone for many weeks, you can just use that information that is formatted in the knowledge graph and just do some rules and figure out, okay, what are the most suspicious sources that I need to check as an analyst in the first place. And if you think about some mission critical situation that time is very important for the analytics, it might save lives to make everything much more faster to just proceed with the investigation. So the summary. So there are a few things that I would like to remember from that talk. So first of all, I hope that you understand after that talk that the knowledge graph can serve as a powerful baseline or the powerful foundation for all analytical projects that may happen in the organizations. The second one is that I hope that you at least remember parts of the knowledge graph creation process, how to create such a platform. The third thing, there are a few important keywords that I would like you to at least remember or just make a image of that, is the knowledge graph itself, the ontology inference, and from my personal reason, entity resolution is also important because, yeah, it's super helpful to have very clean data, and usually this is something that we are dealing with as a data scientist or in general data person. The last one thing is that you might find useful the parsing tools to just make your life easier with parsing the phone numbers and addresses. And the last one but not least is that I hope that you will get inspired by this presentation. And that's all from my side. Thank you very much for your attention. And if you have any question, please let me know or just get me in during lunch break. Thank you.